Hey, what's going on? My name is Anastasio Dalde. I'm going to be recording a coffee filter falling down from the second floor building of my apartment. I did it in Tracker, and as you can see, there's kind of a jump over here. It's because I kind of lost the track of the coffee filter as it fell to the ground. My axis I chose is Y being the positive direction, and I have my time set scale over here. The origin that I put is at the bottom, and so essentially this thing is falling from the top to the bottom. Keep in mind that the actual release point is somewhere way up here. It's at about 1.7 meters, and then it fell down to where my feet is at, and then it comes into the frame of the camera. So the motion that we're looking at is essentially completely linear motion. You can see the graph over here. Here's the position versus time. So here's the vertical versus the horizontal time, and also the data that it spit out. And so you can see that it ends towards the bottom of the screen, and at 2.236 seconds it reached from the top of the screen to the bottom of the screen. My Python graph isn't anything extremely special. One of the things I did was I calculated out the velocity that we were looking at, and then I kind of used that to help me find how I should set up the velocity over here. I initially had this set up so that it was under gravitational force motion, and then I had a resistive force going up, the air resistance force or the drag force pushing against it, and then I had that B set to such a high enough number so that it went into linear motion quick enough. But then the way I figured it is, since I dropped the coffee filter up here, and then by the time it reached the top of the frame, it was in complete linear motion, as I kind of deduced over here. So I got rid of that, and I bypassed that on my programming, and I kind of skipped right over that. You can see that done right over here. If I wanted to keep that, I would not comment out that second half of the equation, but it just basically said that the ballast velocity isn't changing because the initial final velocity is equal to the initial velocity. And then I have the thing pretty much set up. Let's check out what the program does. So you can see, I'm going to zoom in over here. Here's my graph, and it hits the ground, and it tells you the position as a function of time, or it tells you actually the position, and then it also graphs it out for you. When I take all of that data and I put it back into an Excel spreadsheet, let's see, do I want to change the color? No, I don't want to do that. It's going to open up the Excel spreadsheet, and hopefully that will be the same. Let's check it out. So I apologize if I'm talking really quickly, but I only have 5 minutes of time. If we look at this Excel spreadsheet over here, I plotted the time versus tracker, and also I put in the Python. I made the time jumps 0.33 or 0.033 seconds. It's because that was set by my camera frame rate, and you can see over here that that's the case over here, and then I set my delta t on this graph over here to be the same thing, so that I can kind of compare them right next to each other. And I graphed it, and here's what my graph ended up looking like. The red plot over here is the actual lab, or is the tracker. This is what I observed, and then the blue plot is my estimate. I essentially tried to just match up the final velocities and the initial velocities. As you can kind of see, it goes pretty linear all the way until it kind of bumps up over here. And I suppose that could be caused through wind, or as I said, this isn't complete linear motion. It's the force of the drag is pushing up against the force of the gravity, and once those forces equal, it should be perfect linear motion. I gave you the equations of both these graphs, and the slopes, which is the velocities, is pretty similar. We're looking at negative 1.06 versus negative 1.099. I think an interesting thing that you'll see is that when I calculated out my velocity initially, I was looking at velocity is equal to negative 1.24 meters per second. I'm doing everything in meters per second, but the reason why I think it was a little bit off is because that first calculation with the 1.24 meters per second is based off of just the final velocity in the initial or the final position in the initial position, and you can see that the line kind of curves off a little bit towards the end. So I think that this measurement is more accurate. If I change the axes and turn them to a different way, like I called to the right being the positive direction, and I don't know why I would do that. Usually you call it vertical, but say I called down being the positive direction. Essentially all of these numbers would be the same. The velocity would change from a negative 1.06 or a negative 1.099 to a positive, but that's because you're calling down to be positive. So essentially you would have a few more negative numbers to deal with here, but you would have the same results in the end. And that is my graph. So I hope that you enjoyed it, and please let me know what you think and if you got confused. And yeah, thank you very much.